Good afternoon, everybody. My name is Dominic Lucchese, and I don't know how I can follow up that panel, but I'll give it my best. I'm with Bison Peak Water and Power in Tehachapi, California. We are a water power utility company specializing in storage and bulk water opportunities. Our mission at Bison Peak is combining ancient and modern technology to stabilize and revolutionize the industry, ushering in, hopefully, a brighter future. The three projects we have under development are water bottling, bulk water, hydroelectric pump storage with potential for wind, solar, and green hydrogen on our location. The location is Tehachapi, California, about 2.5 hours north of here, in the hub of the #1 renewable source of energy in the state, with producing up to 9 gigawatts of energy production, with more coming online every year. It's also close to a major transportation corridor in the 58 freeway, east to west, the 14 freeway, north to south, with 2 railways stations, one in Tehachapi, California, and one in Mojave. The other main benefit is the Garlock Fault runs directly through the mountain range, which will become apparent here momentarily. The full project overview we have, as you can see on the screen, is it's primarily a hydro pump storage project. We have what's known as we have a very unique piece of land with a flat top mountain and real short runs to the valleys below. With proper planning and proper engineering, we have between 600 and 1,200 megawatts of storage in the center of the renewable hub of California. Plus, with certain available mountain springs, which I will show you here in a few moments, there is also opportunities for municipality water to the city of Tehachapi, the city of Mojave, Lancaster, plus the city of LA. The team heading up these development projects are myself, Ben Lucchese, Mario Lucchese, Chris White, who will be our energy developer, Daniel Su, who will be part of our government relations, and my brother, Vincent, who will be head of IT. Our property is 1,000 acres in the Tehachapi Mountains, encompassing the entire top, plus the entire top and 1.5 miles down towards the Antelope Valley. The lowest point on our property is 5,800 feet, climbs to just shy of 8,000. We've owned this property for over 40 years, and in that 40 years, we have 6 wells. Not one of them has run dry. All of them producing 10 gallons a minute currently, as they sit. The primary reason the idea we have, or the idea up behind this, is what's known as primary water, a primary water cycle. There is a concept beginning to gain steam that a lot of the water we have on this planet actually comes from deep in the Earth's crust. We have the standard atmospheric cycle, which we think of water in the oceans evaporates, goes in the clouds, rains, goes back into the oceans. Well, this new theory is stating that there is also water generating deep in the Earth's crust with the pressure and the heat and the pressure and the heat down there. This water that is generated deep below does find its way up into highly geologically active areas, namely faults and volcanoes. The Garlock Fault is one of them. The Garlock Fault is the largest left lateral strike-slip fault in the Western Hemisphere. In the 1950s, there was a gentleman by the name of Dr. Stephen Reese who drilled a well on the Garlock Fault that to this day, in California City, that to this day is still producing 1,500 gallons per minute out of that well. One of the main key pieces of evidence they have is a substance known as ringwoodite. It's found in these highly geological areas, and it has most of the building blocks needed to generate and create water. All it needs is heat and pressure, which you get down deep below. Here's another illustration, just kind of give you a different view of what I'm talking about. This is an article done by the Northwestern University that goes more into depth of what it is I'm presenting. I want to preface this to say I'm not personally a hydrologist. I do not study this in depth, but they are. They did do a lot of research, a lot of inbound study to develop this theory. Come on. The Lucchese family property, the southern border of the Lucchese family property, has the highest point of the Garlock Fault. The Garlock Fault itself acts as a natural dam. It's on the southern border. As I mentioned, there are currently 6 natural springs on the mountain, on our property alone, plus more in the surrounding areas, which we have not tested, but there. We know they're there. We have confirmation from 3 different hydrogeologic companies over the last decade that have confirmed this. They estimate wells capable of between 300 and 1,000 gallons per minute, with up to 10 different well sites along this fault peak. It's a lot of water. And my thing has stopped working. Anyways. Here's a short little video. Do we have sound? Let me restart it. The gentleman in this video, you'll see, his name is Dr. Paul Power. He is a hydrogeologist. He is also one of the primary revolutionaries for this particular theory. He was one of the drivers behind. He was a student of Dr. Stephen Rees, and he was one of the pioneers that started propagating this particular theory.
Yeah.
This is a joint effort.
Yep.
So remember,
Here you are, pal. What do you think, pal?
well, it speaks for itself.
Look at that.
It speaks for itself. We suspect that we have already, from approximately 60 feet, we are already making somewhere between 200 and 400 gallons of water a minute. Wow. It may very well come in artesian. Once we shut down and the fractures are refilled, we will see what kind of a production. We have excellent quality water. It is 150 parts per million water, which is about as good as it gets.
Wow. Exciting.
So that was Dr. Paul Power. Just as a reiteration, that was a 6-inch test well. It was not finished. We were just drilling to see if we had water, if we could get the volumes of water we need. That was being propagated to us. That 6-inch well at 60 feet was producing between 200 and 400 gallons per minute out of a 6-inch well. It went artesian for 24 hours. Now, all that being said, I'm not here to talk about primary water or magmatic water or deep-seated water. I'm here to talk about the opportunities on this particular plot of land that all this provides us. The number one we have is the most simple, bottling that water. It's clean water. It's good water. It's great tasting. Taste it. I drink it all the time. It's great. You have bottling and canning. The other option is bulk water with the potential that we have there. You have the options to sell water to the local municipalities, which will become apparent here in a moment, as well as eventual hydrogen generation hydrogen gas, as well as power generation. As a lot of the previous speakers have mentioned, there are a lot of mandates coming up, one of them being the inland seaports and the zero emissions trucks by 2027 for the Port of LA. Just a little bit about the bottled water industry. First, since the 1850s, there has been some form of water bottling sold in the world. But today, it has never been more popular than it is today, with up to 1.3 billion plastic bottles sold every day, or 1 million bottles per minute. It's a lot. Just a few quick calculations, just to kind of give you an idea of the sheer volume that we're talking about. Here's a few statistics. 2022 was the largest sales volume in the U.S., in U.S. history. 15.9 billion gallons of these bottled waters. Since then, in the early 90s, there was they were primarily, most of the water bottling was primarily from small regional operating companies. Today, the market is highly concentrated in 4 major brands: Aquafina, Glacial, Dasani, and Poland Spring. Poland Spring, I just learned about 2 hours ago, is actually Nestle. Nestle is one of the largest bottlers of everything and of anything in the world. The second option, as I mentioned earlier, is bulk water option. So BPWP is, I'll reiterate, it was at about 6,000 to 8,000 feet of elevation. The city of Tehachapi uses about 15,000 acre-feet of water per year. Half of that water comes from Bakersfield, or the California Aqueduct, which runs through Bakersfield. 7,500 acre-feet of water per year. Bakersfield is at 400-foot elevation. Tehachapi's at 4,000. They have to pump all that water up the hill with 12 natural gas engines totaling 18,000 brake horsepower. Missions, we want to do we're trying to do everything we can to help the city, both in expansion and also reduce the greenhouse gases. As I mentioned, it's at 4,000-foot elevation. We are at 6 at the lowest point. We're about 15 miles to the nearest connection point, plus about 10 miles from the LADWP aqueduct, which is just south of us. The second option is Bison Peak Pump Storage. The Bison Peak Pump Storage alone is a major supplier, would be a major buyer of that water. Between 2,000 and 6,000 acre-foot of water for initial fill, plus an additional 10% of total acre-foots per year. And additionally, you're going to need a lot of water during the actual construction period of the project itself. And as I mentioned before, we have the potential green hydrogen generation. With the abundance of water and renewable resources in the area, wind and solar, we can utilize a lot of that energy when it is not being used for other avenues. And then eventually hydrogen power generation, though we are still in the early stages of R&D for that particular part of the project. Plus, there are many other ancillary services. The high elevation for firefighting for the area. I'm not sure if anybody's been near one of these helicopters. When they're trying to fly that high and most of them are filled with 10,000 gallons of water, it's a lot of weight. And they're trying to get up to these higher elevations where a lot of the forest fires are, it takes a lot. But if they can take water from up high, it's much easier to fight much quicker. They're able to get on site quicker. Plus the additional tax base and high income jobs all these projects will produce. Then we have additionally carbon credits and any recreational possibilities available to us with 2 separate lakes. We will be talking a little bit more about the Bison Peak Pump Storage tomorrow, So I didn't want to go too much into deep detail, but if you have any questions, please, I want to thank you for your time. If you have any questions, please find one of us and we would be happy to answer anything you have. We are, at this point, we are looking for potential investors and partners to help us grow and become what it is we know we can see this project being. Thank you.